All right, so now we're going to go to section 2.3, measures of location of the data. So this is talking about quartiles and percentiles. Quartiles are really just special percentiles. So the first quartile is the same as the 25th percentile, the third quartile is the same as the 75th percentile, and the median is the same as your second quartile and your 50th percentile. We use percentiles mostly when we have very large populations. Otherwise, percentiles could be very misleading, so you want to make sure you have a large enough population if you're going to use percentiles. The median is a measure of the center of your data. Okay, so it's the middle value, and it does not have to be one of the observed values. Okay, it's just the middle of your data, and it's going to separate your data into two halves. So 50% of your data is going to be to the left of the median, and 50% of the data is going to be to the right of the median. Right, quartiles separate your data into quarters. And so your first quartile is the middle of the first half of your data, and the third quartile is the middle of your upper half of the data. Okay, and remember that your second quartile is the same as your median. So your first quartile is the same as your 25th percentile, second quartile is the same as your median, and the third quartile is the same as your 75th percentile. Now to find the interquartile range, you take your third quartile and subtract the first quartile. In other words, that's the middle part of your data. So the middle 50% of your data is within your interquartile range. All right, so we can use the interquartile range to figure out if we have potential outliers. So a value is suspected of being a potential outlier if it is less than 1.5 of the interquartile range, or it is 1.5 higher, 1.5 times the interquartile range above that. So we're going to go through and do that in a minute. The potential outlier is a data point that is significantly different than other data points. All right, so down here we have all of these different prices of homes. So we have 13 real estate prices, and we're going to calculate the IQR. All right, so we're going to let the calculator calculate our quartiles. So if you go to Stat here, so you press Stat, we're going to edit our list. Now I've already put this in. This has all of the real estate values all the way down, all 13 of them. Okay, so I've already got that list entered in. And if it's in the millions, then it's going to put, in mine, it's set to put it into scientific notation. Okay, so now that I've got my list of data in there, I'm going to hit Stat, and I'm going to go over to the right to calculate, and I'm going to do one variable statistics. In other words, get my 5-number summary. So I'm going to hit 1 or Enter, and then Enter again, and this is going to give me my summary. Now X bar is the mean, this is the sum of my data values, the square of the sum. Anyhow, all of these we're going to talk about in a little bit. I had 13 data values entered in, but you have to hit the down arrow, and once you hit the down arrow, then we get our minimum value, our first quartile, our median, our third quartile, and our max. Okay, so now I know my first and my third quartile, so if I subtract these two, I can get my interquartile range. All right, so our first quartile was 308,750, and our third quartile was 649,000. Our second quartile, or our median, was 4,880. Okay, so you can figure it out that way, or you can have your calculator do it. Either way, it doesn't matter. But when we look for our interquartile range, you do the third quartile minus the first quartile, and this is your IQR, your interquartile range. Okay, and then you do 1.5 of that range, and then we're going to add and subtract this from our first and third quartiles. So we subtract it from the first quartile, and that gives us negative 201,625. Now, you can't have a value on a property that's like that, so none of ours is going to fall below that. So we won't have an outlier that's on the lower end. But when we add this to the third quartile, then, so we take our third quartile and add the 1.5 of the IQR, we get 1.1,559,000, anyhow. So this, anything that's outside of this range is going to be an outlier. That shows, or a possible outlier. So that shows us that the 5.5 million is a potential outlier. All right, we can use a frequency table to help us figure out different percentiles. All right, so we have our hours of sleep on a school night, and then our frequency, relative frequency, and cumulative relative frequency. Okay, so if we're looking for the 28th percentile, that means we've got our cumulative, that means up here, this is going to be the upper end of our 28th percentile. So that means right here's our boundary point. So that 28th percentile is going to lie right between our 6 and our 7, so it's going to be 6.5. So the 28th percentile is 6.5. All right, so when we look for the median, we can use the cumulative relative frequency. So once again, up here, we've got, this means 52% of the data falls less than this. Okay, so where that's helpful is that the 50th percentile is going to be on the upper end of this class. So it's still going to be, none of the 4s, 5s, or 6s are in there, but our 7s are. And so with the 50th percentile, we know that it's going to be the value, or the median, is going to be 7. Okay, because that 50th percentile, or the median, falls within this class. For the 75th percentile, or the third quartile, if you want to call it that, you can kind of see that the 75th percentile is going to happen between your 7s and your 8s. So it's basically like saying it's the first part, or not necessarily the first part, but it's still going to be within these 14 8s that occurred. So we can say that the third quartile has a value of 8. All right, so we can use a formula to find the percentile. So we use k over 100 times n plus 1 to figure out the index. Now the index is just the location in the data where that percentile occurs. So it's like the ith position. It's telling you where located in the data is that percentile. So as we go through this, keep in mind that when you use this, it's not telling you what the data value is, it's telling you the location of that data point. All right, so to use this formula, you have to make sure that your data is ordered from smallest to largest. Okay, so smallest to largest. All right, so if we're looking for the 70th percentile, I'm going to put 70 in for k, because I'm trying to find the 70th percentile. So if I put 70 in here, 70 divided by 100, and then I multiply that by my 21 entries plus 1, we're going to get 21. Now that's telling me the location. Okay, so I go into my list and I count up to 21 numbers, and in the 21st spot is 64. So the 70th percentile, the data value that goes with that is 64 years of age. All right, so going the other direction, let's say that you are given a data value and you want to figure out what percentile that is. X and N and Y represent, so N is the number of total data values, so like just the number in your data. Y represents the data values equal for what you're trying to find, and then so like if you have repeats in your data value, and then X is the number of data values counting from the bottom of your list up to but not including the value for what you're actually looking for, and then you're going to round that to the nearest integer. All right, so example 2.18, going back to the Academy Awards and their ages. So still our list is in order from smallest to largest, and we're looking for the percentile for the age of 58. So in other words, here's our data value, 58, and we want to know what percentile that is. Okay, so the way that we do that is we look to see first how many numbers we have, so that's our n, and we have 29. Okay, now we're going to look how many numbers are smaller than this. So there are 18 numbers that are smaller than that value. So that's where our 18 is going to come from. And there aren't any other 58s. There's only one, so that's why our 1 goes here. And then we put that all together, and that's going to give us 63.8. So we're going to round that to the nearest percentile. So we're going to say that 58 is the 64th percentile. All right, so when it comes to interpreting percentiles, quartiles, and the median, the percentile is just telling you how much is to the left of that, like how much of your data values are less than or equal to that. So this is the information to keep in mind when you're interpreting. So you want to put the information back into context of the situation, include the data value as it represents the percentile, saying what's going to be below that and what percent is going to be above that. But always put it back in context of the situation.